It's video introduction time. Today we're in Alamogordo, New Mexico, and we're going to the National Space Museum here. I used to come here a lot when I was a kid. This isn't too far from El Paso. Are you guys ready? Right here are the
Stand right there.
Of the museum. They have all these cool missiles out here. The kids posing for a picture. They got some one of the capsules, probably one of the Apollo capsules, I guess. I'm guessing, maybe Mercury. Nah, Apollo probably. It's pretty neat. All right, we're gonna try to land the space shuttle right now.
9,000.
How many?
Discovery Houston will show you drifting around the nominal glide path. Continue
Hey,
to follow the guidance.
at 2,000 feet, you're gonna have to air brake it because the shuttle is actually a glider.
Where?
It has no engine.
Where's 2,000
Discovery
feet?
Houston.
They'll tell you.
What do I hit?
You need to try to get the circle on the diamond. You're going the wrong way. Try to get the circle on the diamond.
Discovery Houston, show you a little high. Need to get the nose down.
There you go. There you go. There you go. There you go. Right there. Nice. Keep coming down.
6,000.
It's not picking up on the camera.
Discovery Houston, still showing you well above the glide slope. We need you to get down.
There you go.
now.
There you go.
Radar altitude, checking them. They both look good. Abby's got a lot of light showing there. Guess we better get down.
This is your altitude right here. 3,000. You're gonna have to air brake it.
Where?
2,000.
Right now, air brake it. Yank back.
Okay, how about arm in the gear?
There you go.
Roger, got him.
Like that?
Yep. Now go back down.
Okay, it looks like you had a little trouble with it.
You went too
So
far.
we're going to give you another shot, starting at 3,000.
Just landed that thing, man. I should have been an astronaut. I landed it perfect. It's only because that guy upstairs told me the trick. You got to flare that thing at 2,000 feet because the shuttle has no engine. It's just a glider. So the only way to brake it is to air brake it. See, I always thought that they're right out here. I thought that there was a big crater where a meteor hit, but that's not the case. This is not. I'm misremembering.
Well,
And isn't that what Roger Clemens said at his trial? The guy misremembered. Is this an actual? Yeah, it's a cutaway. Amazing. That's got to be so scary. To strap yourself to a rocket and fly, and that capsule is so. I would get so claustrophobic. Those capsules are teeny tiny, man, and it takes a while to get up there too. It's a long ways.
I think it's days, isn't it?
Well, I don't think it's days, but it depends on where you're going.
What if you're going to Mars?
Well, that would take. I'm not sure. That takes a long time. That's certainly days, more than days. Yeah, for sure. We're racing the children. They have like 80. They have like 80 school kids here today. We're right ahead of them. Two. I actually met this guy. They call him the Rocket Man. I met him at a golf tournament when I was like 6 or 7 years old or something. I remember he gave me a button that said like fastest man alive or something.
Rats went backwards and experienced 83 Gs.
Yeah.
And he said the rats didn't even go into shock. But
Really?
him, on the other hand, he went into shock.
Passed out.
And he passed.
Well, that's more G's than Dr. Stapp did. That's amazing.
Isn't that weird?
Everything's in glass here. It's such a cool museum, but everything's in glass and it's reflecting in the camera. This is the first pressurized suit. You try to use these suits to like sustain your body pressure so you don't pass out. You can actually see, we're on the second floor here of the museum, and you can see out at the base of the mountain all this white line. That's actually White Sands Missile Range. There's the Air Force Base out here, the fast tracks out here where Dr. Sapp broke the land record. And I know the shuttle landed out here at least once at the Air Force Base out here.
First develop an environmental impact statement. First to reusable launch vehicles.
Well, I mean, their state is used so much for it.
Because they realized that New Mexico had predictable weather all year round. And they had the same weather all year, so that's good for them.
We went through the Space Museum, the inside. Now we're going to check the outside out. Actually, the museum, I remember this being a little bit better when I was a kid. There was a whole floor that was closed.
Some people see this and they say it's a UFO.
That's true.
Yeah, look at the picture though, and the picture has wings.
Yeah, this is just the cockpit. But do you see how it has all these angles, all these like straight lines? That's how they advert radar. So they call it a stealth plane. This is little Joe too.
9 rocket motors.
Wow.
Let's see if that's a chip. 1, 2, 3. Only 3.
Was this the sled they used to? Yeah, that's it. Sonic Wind #1. This is the thing that they strapped Dr. Stapp to.
His chair looks like an electric chair.
Isn't that crazy? Could you imagine? And then it flew on rails.
Remember he did it to 632 miles per hour?
Well, they actually have it here.
It's funny, that's what they did.
Yeah.
It does not look comfy.
That is amazing.
That white fans.
What were they? They were checking missiles?
It provided photographic records of missile flight performance.
Oh. This looks like a space telescope.
Newer versions are still used today.
Yeah, that's cool. Uh-oh. We're gonna get run up on by a bunch of kids.
First long-range ballistic missile.
So why is this thing all burned up?
Terror weapon against London. After the World Trade Center.
So the Germans helped the U.S. develop this V2 technology.
It doesn't say why it's all burned
I
up.
said it was just used for research and recovered at the White Sands Missile Range, so maybe it just blew up.
It's all melted over here.
Yeah, it's wild. Dude, this is some serious cactus right here. This thing will mess you up.
I told you, feel the vibration, how it's shaking real bad. Actually, what's happening is the gyroscope keeps trying to fall off the pencil.
Yeah.
But to move off the pencil, it would have to shift its axis of motion so it moves back hundreds of times a minute. And you would detect that as a very rapid vibration in it. You want to try it?
That is cool.
Okay, here. Take the pencil. Now, see the...
Wow.
That's awesome.
Feel what I told you about how it shakes really fast. And that's what's happening. Believe it or not, the gyroscope is falling off the pencil, but it won't let itself fall off. It moves back up on top again.
That's so cool.
And as long as it's spinning fast enough, it'll stay balanced.
Wow.
Now, if you want a really basic thing to do with gyroscope, you just take the gyroscope spinning and sit on the floor and see how long it'll sit there. Now, actually, the outside cage is not supposed to move with it. These cheap ones, there's a lot of friction, so it makes it spin.
Mm-hmm.
But the real gyroscopes, the cage itself is a captive
mounted
inside,
in.
And mounted
Yeah.
in the rocket. In fact, it's mounted on a gimbal that moves around.
Okay.
When you look at those other
Yeah.
gyroscopes, you'll
Yep.
see that they're all gimbal mounted.
Yep.
And that's because the reason for that is when you look at them, you see there's all kinds of connections and stuff hooked on there.
Mm-hmm.
Because not only does it mechanically steer the rocket, it can also control the fins on the back electrically.
Yep.
It can control the engine thrust, and it can send all kinds of telemetry information on the performance of the rocket back to the ground.
That's awesome.
So that's why they that's why they have all the stuff hooked up to it. There's another takes a little practice, but watch this. If we make a loop in the string, put the end of the gyroscope in the loop, and Isn't that weird?
Wow, that's crazy.
The gyroscope would just fall off.
Yeah.
The same thing's happening. Every time the gyroscope tries to fall down, it moves right back up.
Wow, that's crazy.
Now, see, it has to really be moving fast for
Yeah.
that part of it to work, so gradually it loses it.
That's cool.
Now, as it slows down, it starts wobbling. Believe it or not, that wobble is the gyroscope interacting with Earth's rotation. At this elevation above sea level, at this latitude, we're moving from west to... Hey, how fast are you moving right now? Would you believe you are actually moving 810 miles an hour? You
Yep.
can believe it. Actually, you are. But everything around you is moving at the same speed because that is the rotational speed of the Earth at this latitude, at this elevation.
Really?
Just step on that foot pedal and see what happens. Okay, you're making some pretty good lightning bolts, aren't you? Now, we want to try an experiment. If you're a real mad scientist, I'll bet you could hold this light bulb in your hand and make it light up. Just holding it in your hand. So if you'll just hold the light bulb like that and move the end of it real close, don't quite touch it.
Whoa!
Wow, I think you're
It's
a
like a
real
lightsaber.
mad scientist.
I think so too.
Wow, that is cool. Want to try
You
that?
must have special powers.
Yeah, here. Okay, hold the light
That's
bulb.
crazy.
And while he's you can do
Whoa!
it.
Whoa.
You're both mad scientists. Well, let's see if you can do something even weirder mad scientist-wise. If you took Homer's pencil and held it very carefully by the red part and touch the point of the pencil of that ball and very slowly move it down, you might be able to get a lightning bolt to go to the pencil. Touch it. It's awful.
Cool.
Whoa.
Oh my goodness, look at that.
That's cool.
Wow. You think she could do it too?
Can I try it again?
Okay.
Kinda
Hold the red part.
Very Star Warsy.
Okay,
It's like the Emperor, where the Emperor, like, that's cool.
It's just kind of a little parlor trick thing
Yeah.
nowadays. The guy that invented it, Nikola Tesla, had an idea that you could actually have one of these coils in your house and light up the light bulbs all over the house.
Yeah.
And you wouldn't need any wiring. And actually it worked, but it was very inefficient, and it had a disadvantage that all the light bulbs needed to be on or off. Not only that, all your neighbor's lights should be on or off.
Oh.
So
wow.
this field from
Yeah.
this thing spreads out for a long, long distance.
Yeah, Tesla was an amazing
Oh,
guy.
he was. He
Yeah.
was experimenting with AC.
Yeah.
And the particular thing he discovered was the phenomenon of resonance is what makes this work. Theoretically, under resonance, and in fact, not only theoretically, but practically now, you can actually get more power back than you put into it.
Wow.
And nobody understood what was happening until you get let up on the foot switch and let it cool off for a little bit. Yeah.
There you go.
But tingles a little bit on the tip of your finger. But don't do it. If you don't want to.
You can do it.
Everything.
Tessie will do it.
It'd be best for her not to do it, and the reason is the younger the kids are, the thinner their skin.
Oh, yeah.
On your fingertip, your skin's getting kind of thick on there as you get older, and so you can do it. But
Try it,
if you don't want to do it,
try it.
Okay.
I want him to do it first.
Okay, Dad can
I'll do it.
Sure.
Whoa.
Does it hurt?
Not really.
Yeah, and be careful. Don't get your camera too
Yeah.
close to it because if it sparks to the camera, it suddenly erases the memories.
Oh, my God, I don't want to do that.
It's all. It's a
I got all
spark
this good
actually-
footage. I don't want to lose that.
Go ahead. See.
Try it, dude.
Hurt.
You don't have to, dude. No big
You
deal.
don't have to. Actually, it does. It has pure neon gas under 1/100th atmosphere. It's actually a pretty good vacuum. And here is what is unique about it.
Oh, wow.
It lights up by itself.
That's cool.
Now, where this gets into pretty advanced physics, we're actually generating plasma inside here.
Wow.
The neon atom has a total of 10 electrons circulating around it in 3 different orbits. If we put enough energy into the atom, we can cause the electrons to jump out into further orbits. And they'll stay in that orbit as long as the energy is being applied. As soon as the energy is shut off, the electrons drop back, and they will give up the energy they absorbed as photons of light.
Okay.
Now, what's special about this tube is that there is so little neon in here that you can actually see the individual atoms fluorescing. See the graininess in that? You're seeing you are seeing the individual neon atoms being activated. Now, if you strip all the electrons off into outer orbit, you create plasma.
Wow.
In the gas, and that's what's happening.
That's
now,
cool.
Where it's orange, and we're not getting enough energy to create the full plasma effect, and so only the outer shell of the electrons is accelerated, and you get the characteristic orange color of neon gas. Neon lights.
So cool.
Okay, exactly, and that's why true neon lights are orange, because they're neon gas.
Wow.
All right.
But in this case, because the way this tube is spatially made, we can actually generate the full plasma effect.
Cool.
Now, the story behind this tube, this technically was an experimental detonation device for a hydrogen bomb.
Wow.
Built in the 1960s.
Wow.
Okay, the idea didn't work. And it's a very long, involved story how we got a hold of it. It is irreplaceable if it gets broken.
Holy cow.
And if it ever gets broken, I'd rather it be me get blamed.
Yeah, really.
But it's
crazy.
Fact, huh?
It is.